All right, so this is still part of section 2.1a, but I felt myself running a little long in my video, and this topic is important enough and different enough from the last part that I wanted to give it its own kind of emphasis right here, because this is a really important topic that we will talk about several times throughout AP Statistics. And we're going to do an in-class investigation, which will give you guys an idea of this concept. We'll do that. We'll take care of that on our own. But for right now, I'm going to talk you through what we would have probably done by the time you're watching this video. What happened in this problem is we had a big classroom, and we had all the students within the class guess how wide the room was in meters. So the kids' original guesses are written in this group right here. And you can see the guesses range anywhere from like 8 or 9 all the way up to 40 meters, which is quite a bit of variability there, with most people saying somewhere between 10 and 20. Okay, so this is their actual guess. This is going to be our original data sets. And then what happened is we actually told them the answer. This classroom, this hypothetical classroom right here, was 13 meters long. So what we did to figure out how far off each kid was is we subtracted 13, the actual answer, from their estimate. So for example, this kid right here who guessed, 10, I think it's 10. Well, they were 3 meters too low. And 10 minus 13 is a -3. So they'd be one of these dots over here at -3. If a kid guessed exactly 13, well, they would be 0 off, so they would show up right there. If I guess 20, 20 minus 13 is a +7, and I'm like there, or one of those dots. So they have the original graph, and they have, after you subtract 13, now we're looking at the error, or how far off your guess was going to be. So then we got this second graph right here. And on this second graph, first of all, this data set is the same as this data set. They're identical. This just goes by 10s here. This goes by 20s, so it's like zoomed out a little more. But these are the exact same numbers as what you see right here. This was their error, or how far they were off in meters again. But then what we did is we converted their error in meters to figure out their error in feet. How many feet off were you? And in order to do that, we convert it by multiplying by 3.28. So this bottom data set right here is when you take how much they're off by and you multiply by 3.28. So this is how many feet each of their estimates are off by. And that's what's going on with these pictures here. What I want to do with our pictures is look at how things are changing with respect to size. The title up top was transforming data. Transforming is when you add, subtract, or multiply, divide by a number or a constant. And let's talk about what happens. So from our original graph to our -13 graph, the shape of these distributions is the same. They're the same picture, just slid different ways. So shape is going to stay the same. Okay? Outliers. I don't know if there are outliers or aren't. These 3 points are all kind of close together. Maybe you could argue all 3 of them are outliers, but whatever you were going to say, it's the same in both of these pictures. They're equally far away. So outliers is the same between our two graphs. The center of this distribution is very much not the same. The center for this guy would be, I don't know, probably somewhere in here. The center for this guy is probably somewhere in here. Very much a difference in the center. In fact, what appears to have happened here is if my old center is like, I don't know, 12 or 13, somewhere in there, the center of this guy is at 0, and we actually subtract 13 from the center of the old one to get the new one. So the center, when we subtract, definitely changes. Finally, the spread. If you look at this data set on the bottom versus this data set on the top, the points spread from here to here versus here to here, that is exactly the same amount of spread. If you were to calculate the range, max minus min, 40 minus 8 is 32, and I don't know what these numbers are here, but if you subtract that, that's also going to be a range of 32. So out of all of the stuff on this slide, the part that's most not common sense that you're going to have to watch out for is the spread. When you add or subtract, the spread doesn't change. What it does is it shifts everything. But if my hands are here or they're here, my hands are still spread out the same amount. We'll formalize that on the next slide, but just realize spread isn't affected by addition and subtraction. Okay? So now this is going to be the graph we're focused on right here. And we're going to look at the error in feet after we multiplied by 3.28. And again, we're going to look at socks. So specifically looking at the shape of this graph right here, it's more spread out, but I just said the word spread in there. So I'm going to have a difference in spread this time. But the basic shape, I still see two peaks right here. I don't know what you would talk about with regards to skew here. Maybe sort of to the right, skewed to the right, but not like super strong skew. The shape of this one is the same as the shape of this one. So this doesn't change right here. You might argue, well, it's more spread out, but again, that's the spread, which we'll get to. The outliers may be a little difference there. If you look at this versus this, maybe you would call these outliers here where you wouldn't before. So I'm going to put change question mark for outliers. We're not truthfully super concerned about how outliers are affected. So out of all four of these, it's kind of the least important. But it does maybe change there. Center, when I multiply, does change in this problem. It's hard to say exactly where the centers are. I would say somewhere like here-ish versus somewhere like here-ish. So there is a difference in center between these two graphs when you multiply. So center is going to change. And the new one that I already hinted at right here, here's my old spread, about that far. Here's my new spread. That definitely is a difference. So spread is going to change as well. So that is the basic idea that we're getting at right here. And let's go ahead and formalize that on the next slide. So when you transform data, you need to look. In this chapter, we're looking at just what happens when you multiply or divide by a constant. You have to distinguish between adding and subtracting and multiplying and dividing. When you add or subtract by, they're saying to use the number A for each observation, measures of center and location are going to get added or subtracted. So center and location, those are going to change. Actually, you know what? Let's see. The location piece of this, I'm actually going to cross out. That's not that doesn't, if you're at the 85th percentile and everybody gets something, ignore location. So measures of center are going to change when you do this. I'm just striking location from this lesson here. Center changes when you add or subtract. On our first picture, when we were here, or we were here, the center is in two different spots. But measures of shape and measures of spread do not change, okay? So add and subtract, and it basically says this right here, so you don't have to write this down again, don't affect spread or shape. Nothing on this list affects shape. That's something we'll talk about in chapter 6 when we get there. Multiplying and dividing, on the other hand, you're actually going to multiply or divide the center by the number. So they say to use the number B for this one, and multiply and divide the spread. So multiply and divide affects both things, center and spread, whereas adding and subtracting is only center, not spread. And neither thing affects the shape. So let's talk about how that works in an example problem. So we have taxis in New York that charge an additional initial fee of $2.50 and then $2 per mile. And they give us a sweet little linear equation like you were in algebra class, and showed us how you would calculate the total taxi fare. So it's y equals mx with b. It's a 250 plus 2 times your miles. AP stats problems will do this a lot, where they put the variable names in the problem rather than a y and an x, because if you put x and y, you have to define the variables. So they just use the words sometimes. So the taxi person analyzes their info, and they find that the distribution is skewed to the right. The mean for the fares is 1545, and the standard deviation is 1020. So the mean for the fair and the standard deviation for the fair are right here in the problem. They want to know the mean and the standard deviation for the length of the rides, the miles, in other words. So if I wanted to get miles by itself, I would do a little bit of basic algebra here, just like you would do in Algebra 1. I would subtract 250, and then I would divide by 2. So I would take the fair, I would subtract 250, and I would divide by 2, and that would tell me how many miles I'm going to go. We want to know the mean and the standard deviation for the miles. So what you do is you take the info for the variable you do know, which is the fair. Let's say I took the mean, which is a measure of center. I would take my 1545. I would subtract the 250, and I would divide by 2. Subtraction and division both affect measures of center, and when I do this, it will get me my new center for my miles variable, my new mean. So if you subtract those two things, doing that real fast here so you guys can see what we get. All right, so I gotta do 1545 minus 250, and then divide by 2. That is 6.475. So I'm gonna call it 6.48. So the mean number of miles is 6.48 miles. When we look at standard deviation, so mean is pretty much common sense. For the standard deviation, I'm gonna do the same thing. I'm gonna take my standard deviation for the fair. But when I go to subtract 250, subtraction and addition do not affect measures of spread. So that 250 is not going to affect my answer at all. I do not subtract it for measures of spread. All I do is I divide by the 2, and I get 510 for the standard deviation. So when you do the center, you need to do the addition, subtraction, and the multiplication division. When you do the spread, addition and subtraction doesn't affect it. It's only the division that you worry about. So that is something that you'll have to kind of remember and just practice here. Measures of spread are not affected by addition and subtraction. And the last thing right here, I don't want to get too into this right now, but if they standardized all of their fares, when you standardize something, you're turning them into z-scores. And in order to do that, when you make them all z-scores, standardized scores have a mean of 0, and they have a standard deviation of 1. So when I talk about a standardized distribution, the mean is 0 and the standard deviation is 1. In all of these problems here, the shape doesn't change. So when we look at these problems, the original problem is skewed to the right. Addition, subtraction, multiplication, and division, none of those affect your shape. So your distribution would still be right skewed.